Hi everyone, Mr. Armitage here, and today, in this video, we are not doing a proof, we are actually trying to find a particular value. Okay, so we are told that AB, this line here, is parallel to DE. Okay, that's good to know. We are also told that the measure of angle W is 135 degrees, and that the measure of angle Z is 147 degrees. And we are asked to find the measure of BCD, or angle X. How do we do that? Okay, well, we have a couple steps. And in order to find those actual values, we have to rely on a particular thing, a particular shape. Now, our first thought is probably that we see a triangle here, right? If we connected B and D, we could have a triangle, and that would work out just fine. And then we know all the angles in a triangle add up to 180. So since if we make a right angle there, we could subtract 90 off of these two angle measurements, we'd get the little inside bit here, like that. And then we could find that or whatever was left over after subtracting from 80. The problem with that is that B and D are not guaranteed to be exactly across from each other. We have no guarantee of that. So we can't say that if we draw a transversal across it, right, we can't say that that's 90 degrees because we do not have enough information about the location of B and D. So that's out. But notice that we do have two other dots here, A and E. Actually, I'm going to draw a straight line from them, A to E, and whatever. Okay. Now, you might say, how does that help us? Well, the idea here is that because these two lines are parallel, this particular transversal tells us that the angles inside are consecutive interior angles. So angle, we'll say BAE, that's E. And angle DEA are consecutive interior angles. And what do we know about consecutive interior angles? That they add up to 180 degrees. So the measure of angle BAE plus the measure of angle DEA is 180 degrees. Well, how does that help us? You remember the idea that all interior angles in a triangle add up to 180 degrees. The same thing applies to all polygons in the sense that if you take the number of sides and you subtract 2 and multiply that by 180, that gives you the sum of all interior angles. Right? A triangle has 3 sides. So 3 minus 2 is 1 times 180. is 180. What shape do we have here? We got 5 sides. Pentagon. We have 5 minus 2 times 180, or 3 times, keep parentheses, 3 times 180, which is 540 degrees. So the sum of all angles in here, okay, the sum of this angle plus this one plus z plus x plus w equals 540. Measure of angle x plus the measure of angle w plus the measure of angle z plus the measure of angle BAE plus the measure of angle DEA equals 540 degrees. Almost ran out of space. And now we actually know a lot of these measurements, right? We know the measure of angle W. It's 135. We know the measure of angle Z. It's 147. Use a different highlighter. We know the measure of angle Z. It's 147. Now we don't know these 3 measurements. We're trying to find the measure of angle X, but we don't know the measure of angle BAE, and we don't know the measure of angle DEA. But we do know the measure of them combined. That is 180. So we can rewrite this. Measure of angle X plus 135 degrees plus 147 degrees plus 180 degrees equals 540 degrees. Now we add those together. So let's see, 135 plus 147 plus 180, measure of angle X plus 462 degrees equals 540 degrees. Subtract 462 from both sides, and the measure of angle X is 78 degrees. There we have it. The measure of angle BCD is 78 degrees.